Hey everyone, Mr. Hauk here. In today's video, we're going to be looking at examples using the addition and subtraction formulas that we derived earlier. Let's go ahead and get started. So in the last couple of lessons, we derived the following formulas. We have the addition formulas for sine, cosine, and tangent, and we had the subtraction formulas, or the difference formulas, for sine, cosine, and tangent as well. What we want to do today is we want to look at some examples of how we can use these formulas to solve some problems. So let's look at example number 1. In this first example, we want to calculate the cosine of 75 degrees. The problem is that if we look at our unit circle, 75 degrees would be right here in the middle of 60 degrees and 90 degrees. But we don't actually know what the cosine or the sine of 75 degrees is going to be. So we can't look at the unit circle and pull off the exact value. What we're going to do instead is we're going to use one of our new either addition or subtraction formulas, specifically in this example for cosine. So what we have to do is we have to find two angles from the unit circle that when we add them together or subtract them are going to give us 75. But we specifically want the angles to come from the unit circle. So again, we're looking for two angles from the unit circle that when we add them together give us 75 degrees, or when we subtract them we get 75 degrees. So looking at our unit circle, look at 30 degrees and 45 degrees. 30 degrees plus 45 degrees will give us 75 degrees. So we can rewrite the cosine of 75 degrees as the cosine of 30 degrees plus 45 degrees. So what we're going to be using is the addition formula for cosine. Alpha and beta are going to be 30 degrees and 45 degrees. So I'm going to label 30 degrees as alpha. That's a little sloppy though, let's try that again. 30 degrees as alpha and 45 degrees as beta. So let's just follow the formula. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. So this is going to be cosine 30 degrees cosine 45 degrees minus sine 30 degrees times sine of 45 degrees. And now let's use our unit circle to start calculating. Since 30 degrees and 45 degrees are on the unit circle, we can get exact values. So the cosine of 30, well, here's 30 degrees. We know cosine is the x value, so that's square root of 3 over 2. Cosine of 45 degrees, well, here's 45 degrees. Cosine, again, the x value. That's going to be square root of 2 over 2. Minus sine of 30 degrees. Well, sine is the y value, so 30 degrees, the y value is 1/2. And then the sine of 45 degrees. Here's 45 degrees. The y value is the sine, square root of 2 over 2. Okay, and now let's go ahead and calculate. Square root of 3 times square root of 2, when we multiply two square roots, we multiply the numbers under the square root together. So this is going to give us square root of 6. Denominators, when we're multiplying, we multiply the denominators together, so that's going to give us 4. Minus 1 times the square root of 2, that's just going to be square root of 2. And then the denominators, 2 times 2 is going to give us 4. Notice that these both have a common denominator of 4, so we can combine the numerators, and we get square root of 6 minus square root of 2 divided by 4. And this is an exact answer. Notice we want an exact answer. So we don't want a decimal approximation, we don't want to try to use the TI-84 calculator or Desmos or anything like that. We want the exact answer, which is what we have right here. Okay, so the cosine of 75 degrees as an exact answer is the square root of 6 minus the square root of 2, all divided by 4. Let's try a couple more examples here. Here, let's try a tangent example, and you're going to see this one's going to require a little bit more work on our part, as far as the calculating goes at least. So tangent of 15 degrees, again, we want to find two angles from the unit circle that either when we add them together give us 15 degrees, or when we subtract them, give us 15 degrees. So looking at our unit circle, well, I'm actually going to look at the 45 degrees and the 30 degrees again, but instead of adding them to get 75 degrees, I'm going to do 45 degrees minus 30 degrees to get the 15. So I'm going to write this tangent of 15 degrees as the tangent of 45 degrees minus 30 degrees. Okay? And now, since this is a subtraction formula, let's follow the subtraction formula for tangent. We're going to have tangent of alpha minus tangent of beta over 1 plus tangent alpha tangent beta. So this is going to turn into, just following the formula, tangent of 45 degrees minus the tangent of 30 degrees over 1 plus tangent 45 times tangent 30. Okay? Now let's look at our unit circle and pull off these tangent values. So tangent of 45 degrees, well, here's 45 degrees. The tangent is 1. So on this unit circle, the tangent values are in the rectangles. So tangent of 45 degrees is 1 minus tangent of 30 degrees, which here's 30 degrees. The tangent is square root of 3 over 3 over 1 plus, and let's see, tangent of 45 degrees, we already established that's 1, times tangent of 30 degrees, which we've already established is square root of 3 over 3. Okay? Now, we definitely don't want to leave our answer looking like this. We know that in math, we don't like square roots and denominators, so let's start simplifying some of this stuff here. 1 minus square root of 3 over 3, I want a common denominator of 3, and I can rewrite 1 as 3 over 3. And notice now that they have a common denominator, this is going to simplify to 3 minus square root of 3 over 3. So here's our new numerator, 3 minus square root of 3 over 3. Looking at our denominator now, we're going to do something very similar. This 1, I'm going to rewrite as a 3 over 3 so that they have a common denominator of 3. That was a terrible 3 right there. So 3 over 3 plus square root of 3 over 3. Add the numerators together, 3 plus square root of 3, common denominator of 3. Okay, a couple things to notice. These 3's are going to cancel because they're both in the denominator. So what this is going to simplify to, and I'm going to draw a little arrow over here, this is going to simplify to 3 minus square root of 3 divided by 3 plus square root of 3. Now, even though we've started to simplify this a little bit, this is still not in simplest form because, again, we still have this square root in the denominator. So what we want to do is we want to multiply by the conjugate. And remember, when working with square roots, the conjugate is going to be whatever the denominator is with a subtraction sign, or with the opposite sign, basically. So we're going to multiply top and bottom times 3 minus square root of 3. And the reason we do this is we're going to see a lot of things cancel out. And it's going to, specifically in the denominator, the square roots are going to cancel, and it's going to make the problem look a lot nicer. So let's go ahead and start foiling. 3 times 3, that's going to give us 9. 3 times negative square root of 3, that's negative 3 square root of 3. Negative square root of 3 times 3, that's another negative 3 square root of 3. Negative square root of 3 times negative square root of 3 is going to be positive 3. So there's our new numerator. And the denominator, 3 times 3, that's 9. 3 times negative square root of 3, that's negative 3 square root of 3. Square root of 3 times 3 is going to be 3 square root of 3, excuse me there. And then square root of 3 times negative square root of 3 is going to be negative 3. And simplifying some things, okay, in the numerator, 9 plus 3, that's going to give us 12. Negative square root of 3, negative square root of 3, they have the same square root, so we add the numbers on the outside, that's going to be negative 6 square root of 3. In the denominator, notice negative square root of 3 and positive square root of 3 cancel. 9 minus 3 is going to give us 6. Okay, we're almost done simplifying here. Here we have 12 minus 6 square root of 3 on top. We have 6 here in the bottom. Notice that both the 12 and the negative 6 square root of 3 can be reduced by 6. So this is really like saying 12 over 6 minus 6 square root of 3 over 6, which is 2 minus the square root of 3. Okay, and that's our exact value, even though it was a lot of work. That is our exact value for the tangent of 15 degrees. So both of these examples, number 1 and number 2, notice that both of them dealt with degrees. Examples 3 and 4 are going to deal with radians, so we need to get used to working in radians again. In this example, we want to go ahead and calculate the exact value of the sine of 5 pi over 12. So one thing that I think is a really good idea, and you're going to see this on my unit circle, is that all the different radian angles, if you look at them all, you know, pi over 6, pi over 4, pi over 3, pi over 2, every single denominator is either a 2, 3, 4, or a 6. And if you think about it, a common denominator between all of them would be 12. So what I've done is I've converted every single radian measure to have a denominator of 12. So pi over 6 is really 2 pi over 12. Pi over 4 is really 3 pi over 12. Pi over 3 is 4 pi over 12. And I did this all the way around the unit circle. Okay, so if you need to, pause the video if you want to write those down, if you want to write down the radians converted to have a denominator of 12. But the reason I'm going to do this is because they're all going to have a common denominator, and it's going to help us when trying to find the radians that we want to add or subtract to get certain radian measures. Okay, so for example here, we have the sine, or we're trying to calculate the sine of 5 pi over 12. So we need to look at our unit circle and think what two angles, what two radian measures are going to add to be 5 pi over 12. Well, notice that, you know, pi over 6 is 2 pi over 12, and pi over 4 is 3 pi over 12. Well, 3 pi over 12 and 2 pi over 12, since they have the common denominator of 12, 3 pi and 2 pi add to 5 pi. So that means pi over 4 and pi over 6, if I add them together, equals 5 pi over 12. So that's what we're going to use here. We're going to say, okay, well, the sine of 5 pi over 12 is equal to the sine of pi over 6 plus pi over 4. And again, remember, this is because pi over 6 is really 2 pi over 12, and pi over 4 is really 3 pi over 12. And you add those together, you get 5 pi over 12, okay? We can see here pi over 6, this is our alpha, pi over 4, this is our beta. So we are following the sine addition formula. And if we follow the sine addition formula, this is what we're going to get. We're going to get sine of alpha, or sine of pi over 6, times cosine of beta, or cosine of pi over 4, plus cosine of alpha, or cosine of pi over 6, times sine of beta, or sine of pi over 4. Now let's jump over to our unit circle and start pulling off these values. So we want sine of pi over 6 first. Here's pi over 6. Sine is the y value, so that's 1/2. Then we want cosine of pi over 4. Well, here's pi over 4. Oh, let's not get that. Let's get the, there we go. Here's pi over 4. Cosine is the x value, so square root of 2 over 2. All right. Now we'll do cosine of pi over 6. Here's pi over 6. Cosine again, x value, square root of 3 over 2. And then lastly, we want the sine of pi over 4. Well, here's pi over 4. The sine is the y value, square root of 2 over 2. And let's start simplifying. So 1/2 times square root of 2 over 2, that's going to be square root of 2 over 4. Plus square root of 3 over 2 times square root of 2 over 2, that's going to be square root of 6 over 4. They have a common denominator, so this is square root of 2 plus square root of 6 over 4. Also notice that I could have written this as square root of 6 plus square root of 2. We know that addition is commutative. I could have written the numerator in any order. Okay, but that is our exact value of sine of 5 pi over 12. All right, last example that we're going to do here in the notes. Number 4, we have sine of negative pi over 12, so we're going to deal with a negative angle. And there's actually a couple different ways that you could handle this. You can either keep it a negative angle, and that's what I'm going to do in this problem. Or if you wanted to, if you remember back to coterminal angles earlier in the course, you can find a coterminal angle by adding 2 pi to it. So you could do that if you wanted to, and get a positive angle and deal with it that way. But I'm going to keep it as a negative angle. So I want to find two angles that, if I add or subtract, in this case is going to be subtraction, are going to give me negative pi over 12. So looking at this right here, well, what if I take 2 pi over 12 and subtract 3 pi over 12? Okay, that's the first one that I notice, because 2 pi over 12 minus 3 pi over 12 is going to be negative pi over 12. Well, 2 pi over 12 is pi over 6, 3 pi over 12 is pi over 4, so I'm going to convert this to the sine. So sine of negative pi over 12 is going to equal the sine of pi over 6 minus pi over 4. Again, that's because pi over 6, that's 2 pi over 12, pi over 4, that's 3 pi over 12. And if I were to subtract them, I would get negative pi over 12. So pi over 6 is our alpha, pi over 4 is our beta. Let's go ahead and calculate. So we are using a sine subtraction formula. We can see that right here. There we go. So let's follow that formula. Sine alpha cosine beta minus cosine alpha sine beta. So sine alpha, that's sine of pi over 6. Cosine beta, that's cosine of pi over 4. Minus cosine alpha, which is cosine pi over 6, times sine beta, which is sine of pi over 4. All right, sine of pi over 6. Here's pi over 6. Sine is 1/2. Cosine of pi over 4. Here's pi over 4. Cosine the x value, square root of 3 over 2. Oh, sorry, not square root of 3 over 2, square root of 2 over 2. Almost made that small mistake. Then we have our minus cosine pi over 6. Well, pi over 6 right here, cosine, that's square root of 3 over 2. And then lastly, sine of pi over 4. Well, here's pi over 4. Sine value is the y value, square root of 2 over 2. Okay. And now let's calculate and simplify. 1/2 times square root of 2 over 2, that's going to be square root of 2 over 4. Minus square root of 3 over 2 times square root of 2 over 2, that's going to be square root of 6 over 4. Which is going to give us square root of 2 minus square root of 6 all over 4. Okay. What I'm going to do now is I'm just going to real quickly show you 4 other examples. I'm not going to work through them though. What I would encourage you to do is I would encourage you to pause the video and try them on your own, and then unpause the video here in a few seconds and see if you got the answers right. Okay, so these 4 problems are on the back of the notes. It's numbers 5 through 8. Again, I would try them on my own and then come back to this video and check your work. Okay, so here's the work and the answer to number 5. Here's the work and the answer to number 6. Pause the video if you need to. Here's the work and the answer to number 7. And here's the work and the answer to number 8. Okay. Hopefully this video helped you out, showing you how we can use the sum and difference formulas that we've been proving the last couple of days to really show you how you can put them to use with the unit circle to find exact values of certain trig functions.